Okay. Now we will review some orders in part. Okay. Now about shell. Okay. We know that shell here you text your write your thickness, what thickness you need, and click open face and OK. But if I need this thickness 2 millimeters and this thickness 4 millimeters, I need to change thickness between walls. Okay, the same order, but we have extra options. Shell. These 2 millimeters or this place, this position of number, meaning the common thickness. The common thickness of the part. I mean, I have part consists from at least six faces. Okay, I have 5 faces with 2 millimeters. This means that these to me are common. Okay, these faces are common. And select your opening normal. Here, this one, select the face that you need special thickness. I need for the base 10 millimeters. Click OK. Let's check. 2 millimeters for all, and the selected face has changed to 10 millimeters. Okay. I need this face also, but this face will be with 5 millimeters. This with 10 and this with 5. Okay. Two, 10, 5. It's okay. Multi thickness for one part. All right. Okay. Now we'll turn about if I need to make a forming tool, create your own forming tool. Yesterday we used the forming tools in library, okay, like louver, like impulses, like something like that. Now if I need to make my special tool, okay, so I have a special tool for a special project, and this tool will be manufactured its die at supplier and will be used with our factory. Okay, so you need to design your special tool. How can do that? First, let's make a quick lecture about concept of die. What's a die? If you have a sheet metal, you have a sheet and have something like that. Okay, if I will give section, you will find it like that. Understand? About clear? Not clear? Excellent. Okay. I cut. Okay. Alright. This is called forming tool. That we made yesterday. But what's the concept? Just punch and die to form this reality. Okay. An action. you will make punch and die. What the punch will be like that. Which,
excuse me, sir. Mawawag sila na. Pagkawa daw ng extension sa AG. Tapos nalagay yung effort. Excuse me, sir.
okay.
I have something urgent from you.
All right. 50%. Okay. All right. This shipment. Okay. Punch and die. Okay, that's shipment just between them. Okay, this fix it, this die, fix it. Okay, and this punch move away, up down, up down, up down. Alright, finally go up and down, up, put your sheet metal down, up. Okay, it's a main concept. Let's see something. Sorry, I can't stop because I haven't time just this week only. Okay.
Anyway, some videos they get the videos. If
Yeah.
they will be submitting,
Yeah.
you can watch the videos and
Yes, I need to do something for you. After this lecture, I need to see your problems. Okay? We'll spend the other times, the rest of period of training. Just we have today only. We have what? Today is Monday. Monday. So we have only Tuesday, Wednesday, Thursday, and next Saturday. Okay, Saturday. Okay, last day for me with you is next Monday, because at morning I will travel. Okay. We can make a review, solve problems that you have, things like that. Okay. Now with YouTube, I need to show you something. See this part? This is a die, but do a progressive, a lot of operation. Very, very complicated mechanism. See these steps of sheet. See the steps? Each step of this mold, okay, this die, forming one of them. Finally, you will find the part out. This part, right? Okay, around cut. Okay.
If you write anything on your computer, you need to get grounded.
I write pretty much all day.
You can import any 3D model to Solidworks. Put it as a project or like you can import any 3D model.
Yeah.
Solidworks.
Yeah.
What format do you like?
File
The one that
open.
we try is
All these types. STL, STB, Adobe Illustrator, Adobe Photoshop في PSD file. Okay, Parasolid, IGS, STEP, ACIS, 3D manufacturing format, another softwares, software called Katia, software called Pro Engineer, another software called Unigraphics, NX, another one called Inventor, Solid Edge, Cat Key. No, you can import any 3D drawing will be open. Any 3D drawing.
Max file also, 3D Max file also.
Yes, you have Max. You can export if you're from 3D Max. We did this one time at the first. Yes, you can export from 3D Max, IGES or STL or STB. Okay, and you can import it. Okay, I don't have any problem. I think that we have a file. We made it before my training. If you have any file on 3D Max, can be opened normally, no problem. But convert it to IGES or STL.
We made a larger version, so it's a little hard to get a show the video, but that's 3 inches, 6 inches across.
Not this, no, not this one that we need. Punching. Mid. Punching tools. Yes, this type of punching. See? Heavy mechanisms. Okay? Cam flange, See the system also. See, I need to make extra pending, internal pending. Concept clear? Just the idea. There are a lot of ideas you can use and like that. If you know the concept, you can create any idea you need. Okay. 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 So when we need to create our shape. For example, if we have need to create the U of Unigraf, the U shape. Okay, we need to make it as a punch to put it in sheet metal. You will create the punch only. You will create this one. Okay, we will create. Now we will draw the punch. Okay, and convert it to a sheet format. Sorry, a forming tool, and put it in library. Let's see. I need the U shape. U letter. This U shape. For example, you have this extrude will act the deeps that you need in sheet metal. I need 3 millimeters only. And create. This will be a bunch. You see? Yes. Nolly, understand the idea? Okay. So, let's identify Nothing. This punch should have fillets. Okay. For example, that we have fillets. Two millimeters, and another fillet, 1 millimeter. Five, for example, and increase this one. Is a punch. Alright. Go to sheet metal, forming tool. Forming tool. What's this one? Stopping face. This face. This is a stop, the end. When you're punching, this is the end face. Okay? That's stop. Faces to remove, we haven't cut. It's only forming. Okay, so just click. Automatically we change the colors. File, save as. In this form tool. Save it as a form tool. And we open to you the library of default software default library. It's okay. You can, no, I don't need this one. Go to your library, pause. For example, libraries. This is my place. 3D CAD library, forming tool. Unigraf punch, for example. Save. Finished. Close. Not need to save this part because saved as already at forming tool. When you go to your sheet metal part, go like that, 2 millimeters for example. 3D CAD library, forming tool, you will see Unigraf punch. But first we should right click and forming tool folder to activate it as forming tool.
What about if you will save in another location?
What about what?
You can still get it. You save in another location. For example, you save in desktop.
Location?
The
Oh.
forming tool.
Yeah.
You will say, for example, you say if it's the same, you say in desktop. You can still get it.
Yeah, okay. I will show you the location. You mean the location of this one?
Yes, sir.
Yes, I will show you. Like yesterday, would be normal forming tool with all flip can working also. The same options that we use the same, but your own forming tool. Okay. So the position, the place of new library. If you remember options that we made before, options, file location. From file location, if you remember, we make new templates. Design library, and we add this one in design library. Add your new path. Okay, so automatically after okay, you will find it here. 3D library, the same folder name that I have here. Yes, 3D CAD library, the same. because this folder is this already. Okay, and make a folder called forming tool and right click on this folder and sign activate this forming tool folder. Okay, so this folder now will be okay, will be ready, meaning that any forming tool file will be in this folder, will be applied as a forming tool. This one, no, it's very, very small. I will show you something good for us like that. It's very, very small also. Okay, covered. I covered you. Let's check together some orders in this sheet metal. When we used this one, we used only edge flange. Okay, but you have a lot of orders you can use. It's very good and save more time. Like him. What's this him? Yeah, right click, you can change him type. This one like that, this one, and change dimension. This one, and if you make flatten, will be okay. Flatten. See, you can flat. Jog. Just click on the face and draw any sketch you need, like that, for example, and click fixed face. I need this fixed zone. This zone will be moved with dimension need and the angle. For example, also if you need to flat, it's okay. Alright. Okay. If you notice that these all features draw the sheet metal in bending mode, meaning that you will start with your own flat and bend edges. Okay? But if you have special case that you have already the flat one, you have the flat sheet, and you need to bend it like press brake. You can use this one. Just sketched bend. Just okay. I need to bend at this center line with this dimension, for example. Sorry, not dotted. Okay, click on sketch bend if you have a sketch. Fixed face, yeah. This is a fixed area. He will move the another one. If you will select this fixed area, we'll move this one. Okay. Alright,
also use that for the charging station, right? That
Yes, but in charging station, and this feature, not recommended to use, when you make a new design. Okay, only we use this feature when you obligated on AutoCAD file that you received from client. Okay, you obligated on it, and you need to you need to paint this file. Okay, entire this dimension of AutoCAD. So now you are locked with the AutoCAD file, with the dimension of his sheet. Okay, but in the charging station we adapt the lock, we create pins, we create joints, we create all things. Okay, and finally get the planting. Oh,
Just want to join.
okay. So this feature recommended to don't use it only when you will be obligated on special size of sheet. Okay. Also you can flat. Haven't a problem. All right. Okay. Save it. File. Port. Sheet metal. You can draw this base with 200, for example, by 300. It's okay. Select your thickness. Right. Okay. Miter flange. What's the miter flange? In miter flange, you will select only edge and draw any bending shape you need. Need this, like that. Any bending shape. See, very complicated. Huh? And go. Okay. You can select. Okay.
so it was like the same shape that we
Yes. Flat. Okay. Okay. It's a complicated shape, really. You can do it manually. Also without AutoCAD you can do. Okay. But when you use sheet metal and flat it, yes, you can flat. Okay. And bend these bending lines. You will use it with your bending press plate machine. Okay. You can do just laser cutting. Okay. All right. Okay. Now it's very clear to you now. Clear. Okay. Now we will discuss a real case study, a big problem for all sheet metal manufacturers. If you have a board like that, pendant, okay, and here in this bending radius, you have a cutout, circle cutout. Okay? This circle cutout, okay, after planking, will not be a circle. After planking, will not be a circle. Okay? Sure. Let's check together. Now, if you have a sketch,
Hold on a second. Hold on. Guys, in training, we need you guys to draw. You have paper?
Yes.
Draw. We want you to draw. If he does, we want you to do. I'll give paper. Draw.
Take it.
Notes, please. Draw.
Okay, just sketch. If you go with sheet metal and edge flange will be converted into sheet metal, just extrude it with a thickness. Okay, reverse direction, in out. Now I draw this line, reverse, clear. Okay, this means if your dimension that you measure here, this one 70 by 70 was internal dimension or external dimension. Okay, this radius, if now I have a cut, so I will create something like that, sketch, and here I will go with cutting, and cut out, for example, through all pores. So you can do. Why? Because it's sheet metal. It's a sheet metal. Okay, so you need to cut it before bending. Laser cut. Okay, you will cut this circle before bending. After that, go to press brake and bend the sheet metal. All right. Okay. So here we have unfold and fold. Unfold and fold. Okay. There's a big difference between flatten and fold and unfold. Why? This flatten will be your last order, meaning that you finished already your part and you are ready to export it to a DXF. So when click on flatten, you will find all icons has been deactivated, right? So you happen to do any feature after flatten. So flatten is the final step. Fold and unfold makes the same action, but you can use it as a feature. You can use it as a feature, like cut, like jog, like corner, like anything. Okay, so fold. What is the fixed face? For example, I need this one, will be the fixed, and I will select this bend, click OK. Oh, sorry, we need to unfold first. Okay, this fixed face, and select this one. Okay, but all icons already activated. Okay, go to cut, and make any shape you need. Yes. Link to thickness. Okay, normal cut. All right, and create fold. Select your bending.
So, 1 minute. This is production design. So let's say the client gives them a design of a concept,
Yeah.
and we need to produce a prototype or exhibit applying that concept. It still needs to be made by us, yes? Am I right or am I wrong? So the client gives you this, but for production, you guys do the design for that, yes? So this is what he's referring before. You are doing design. This is production design. The client gives you the conceptual design,
Yeah.
and then you have to design it more using this for production.
Yes.
What software are you using now for this, for design, for production?
AutoCAD, mostly AutoCAD.
Okay. So give me an evaluation of AutoCAD. Compared to this, give me a comparative analysis. I need to know AutoCAD, SolidWorks, pros and cons. You should have something to say. You guys, you've been training them how long? 2 weeks, yes?
2 weeks, yeah.
2-3 weeks, yes? So give me an overview. So because the shipper needs to know what you guys, we need feedback. AutoCAD, SolidWorks.
Make
Functionality, which one has the most functions? AutoCAD? Okay, so here we say functionality. Alright, what other issues I would want to say? Speed, which one do you think you can work faster with? AutoCAD or SolidWorks?
For me, because you don't still don't know this one.
Once you, okay, that's the point, of course. Once you know them, once your knowledge becomes par, which one do you think will make you more productive?
For sure, this one is
Okay.
very good.
also accuracy.
Accuracy, yes. Which one's more accurate? So the only benefit from what I'm hearing now with AutoCAD is that you're familiar with it. That's the main benefit. So
And this is more harder.
hmm?
And this is more harder to learn.
Well, guys, this is the point. Not really. It's not harder to learn. Maybe it's more to learn. And that's the point. The point is, as we grow as professionals, we need to take time to learn how to use the tools. For example, at one time I was in the engineer corps. They have manual hammer. You understand? If you want to put a hole into granite, a solid hammer will take forever. Then we have jackhammers. A manual hammer is very easy to use. A jackhammer difficult because you have to connect it to a pressure trailer. You have to know how to run the hose, the oilers, all these different things. There's some PPE involved because it's far more pressure being produced. You have to protect yourself. But you're far more productive. We don't just stick with the old manual hammer because it's easy to use. How long will it take you to beat through a slab of granite? Forever. Not hard at all. And now they have vehicle-mounted jackhammers, pneumatic tools. You just drive the vehicle to the spot. It's mounted on a truck. The operator just uses joysticks, find the spots, goes through. No one's holding jackhammers anymore. We have to advance ourselves to elevate the company. This is the point, to elevate yourself. Where do you want to be in life? Do you want to be in the same place? Where are you from? Huh? Islamabad. You're not in Islamabad now, yes? So you decided you wanted to go somewhere with your career. Am I right or am I wrong? Okay. So to keep on that journey, we always have to refresh our energy, our memory, our skill set, even our energy. I need to see some excitement. I want to improve myself. I want to bring something better to the client. Other question. When the client sends you design work, what format do they use? Is it usually AutoCAD or what other software do they use? Or do you know? What software are the client using? When they give you a design, what format is that in?
Mostly, yes, 3D Max.
3D Max.
Yes.
So are they using AutoCAD? Is 3D Max AutoCAD or something different?
3D Max just only designs the full view, but technical.
For technical, we have to use AutoCAD.
Okay.
That is
And the
not
client sent us the 3D Max file for the view.
Just the
We have
views.
to prepare the technical in the AutoCAD for the production.
Okay. Alright. So they don't give you any technical drawings, just 3D view.
No, they are sometimes they are visuals.
Okay, what software they use for the technical? AutoCAD. So they're not using SolidWorks.
No.
You've never seen SolidWorks before. Alright, now, here's another point. Just because you don't see other people using it, doesn't mean that you shouldn't use it. Because you'll be impressive if they see you having more than what they have. Usually when you give work to somebody else, you do this because they can do something you can't do. So, if I need to get the laptop fixed, am I going to send it to somebody who knows less than me or more than me? More than me, yes? If they don't know more than me, I can do it myself. So if they're using AutoCAD, fine, humble them. But when they come to us, we want to say, you come to us because we have more to offer. Again, we're not the market followers, we're the market leaders. Clear? All right.
Okay. All right. So now we know what's a forming tool. Okay. We created our own forming tool. All right. And we know these features. Okay. With final one with miter flange and fold and unfold. All right. Now we're working on something on job training. Now, if you have a complicated shape and you need to make it not with foam, not with polyester, you need to make it with sheet metal. Okay, I will show you a real case study of our business.
While you're doing that, I have a quick question. There's a point said data migration. So if a client was to give me an AutoCAD drawing, could we import that into Solidworks
Yeah.
to modify?
We made it before with this train, with the train that they have. We made this one. It's a training folder. We just imported this one has been imported from 3D Max as an image. Okay, we made it on the third lecture, I think.
Okay, can AutoCAD do that? If it's a different format, can you import it into AutoCAD? SolidWorks. If someone gave you a SolidWorks file, could you import it into AutoCAD and manipulate it?
Yes, we can change the format and we can open in AutoCAD.
You can open this drawing up in AutoCAD.
We can change the format.
No, if you have a 3D Max file, you can't open it on AutoCAD, because AutoCAD like that. If you find this draft side, left side. Sorry.
So let's make this perfectly clear. You cannot import this in AutoCAD. This is very important.
Solidworks file, can we change the format and we can open in
No. If you
Okay.
now you asking about sheet metal, okay? Sheet metal just 2D like that. You need, if you have a AutoCAD file, just 2D, okay? But okay, this is okay. We made it before when you import a AutoCAD file into SolidWorks, okay? Workstation, charging station is a real case study that we made, okay? But if you need to make inverse, you can't. You can't go from SolidWorks to AutoCAD. But you can get from AutoCAD to SolidWorks.
Do you guys understand this? Yes. Why this is important? Now the issue is that if we want to expand our client base, I want software that's powerful enough that you can migrate the data into your system and manipulate it, no matter what file they have. I thought this AutoCAD doesn't have that functionality, doesn't have that ability. Do you understand? Just because this market now isn't using SolidWorks, you can't think you'll never come across a customer that will use SolidWorks. If they give it to you, what are you going to do with it? Redraw the whole thing? Okay, continue. I just want to make that point.
See the shape? This is a complicated shape to make it from sheet metal. Okay, this was made really in sheet metal. Okay, but how? There is a technology to make it sheet metal, manufactured normally. Sorry. Okay. If you need to draw this with sheet metal, you can't do directly. You can't draw it directly because you don't know these angles how to be connected each one together. It's very difficult. Okay. So let's check together. See, this design first has been designed with surface. Do you remember surface that we made it before? Yes. We used surface in train in the hyperloop. Okay. Okay. How? Now, if you have this complicated shape, you start working with lines. This is a baseline. 3D sketch, do you remember? Good. And start working this 3D sketch that you haven't any coordinates. You just X, Y, Z. See? I haven't any coordinates. You're working in the space.
Can you do this in AutoCAD?
No, we are not working 3D AutoCAD. We can. It's in 3D.
Huh?
3D AutoCAD.
You can.
We don't know to make 3D.
But the difference between this 3D and AutoCAD,
Yes.
AutoCAD, you can't use parametric dimensions. In AutoCAD, you should put
Square.
the dimensions first and get drawing. And here, you make drawing first
And then-
and put dimension. Okay, so the dimension, if you change dimension, it changes the shape. Okay,
Yes.
in AutoCAD, you can't do that. Okay, if you you draw something like that, I will show you. Draft side, draft side, draft side, draft side.
No, I understand.
Yes, should you used AutoCAD before?
Yeah,
Because you are a civil engineer. It's it.
In modification, this is not there.
And in that, first, when I get this order rec, should start corner and get thickness and line width, something like that before. Okay, after drawing and put my dimension here, I can double click on this dimension to change it to 17, for example, and the shape will be changed with me dynamically. You can. You can. Okay. This one is 6.0. I can change it if I need to change this line. Double click. I can double click on dimension and change it to 5. And this rectangle would be actually go to 5.
Yes.
Okay. You should make here an offset and change these lines and put endpoint to another endpoint.
Yes.
Will take more time.
Yes.
Okay, but in SolidWorks you can use directly change your dimensions according your shape, according your relations. Okay, it's a parametric software. It's the difference between AutoCAD and this 3D software. It's a parametric software. Okay, so in something like this shape, it's very complicated to do, but you can make constraints to lock your file. So now I will constrain this one with this dimension 50. Change it. The line has been changed. This dimension. Go to this one. Also center line. Sorry. Also center line. And snap to this midpoint. See. And go to Y. Sorry, to Z or X. Okay, change. Align to X.
So
align to
this
Y,
technology
Z.
is called smart dimension.
Yeah, smart dimension. Yes,
So this is the capability.
smart dimension. Also, in this way you can start draw it again, something like that. Line, put this line anywhere, okay, and go with y will be vertically, with x horizontally, with z horizontally but in z direction. Right click, midpoint, coincident, put dimension, and lock also this one, converted to black line. And we said before that black line meaning fully defined. Fully defined meaning that have all dimensions that entity need. Okay. Okay. Now you have a 3D, just lines. Can hide this one and right click, edit, sketch this 3D and create your lines. Okay, good. Now we'll go to surface and we'll use loft. Do you remember lofting surface? Check this one, this line, okay, with this line, okay, this guide, okay, and this guide, okay. Alright,
Yes.
profiles and guides. First, face. Right click and show. You sketch. Loft. This one. This one. Also guide. This guide. Okay. Loft. This one to this one, use this one, okay. So you lofted, this one, use this one. It's okay. And how I do sketches here. Now you have a fully surface port. Okay. If you need to convert this to sheet metal with specification of sheet metal, thickness, key factor, bending radius, okay. In sheet metal you have something called convert to sheet metal. Convert to sheet metal. What's order mean? Mean that you will convert any feature model, each model created with features or surface to sheet metal environment. Convert. He will ask you some questions, logical questions. Okay. First, where is the base of the part? Any sheet metal part should have a base. Okay, should have base face. Okay, like your workstation, sorry, charging station. We have this one, light plate. Okay, this will be our base. Okay, and all other edges. Okay.
So let me clarify. So what this can do is, from design, it can convert design to material specifications once you define the material.
Yeah, yeah. We made it yesterday, stress analysis,
Okay.
and
You did
yeah. Yesterday is lecture of yesterday.
tensile test, all this different stuff.
I'll give you the video. Yeah.
Okay, good.
Okay.
On YouTube, you can go just try Unigraf.
Ah.
Unigraf, you can see the videos of
In YouTube, Unigraf channel. This one, yeah.
Yes.
This one. Put any
Yeah,
image.
logo, yeah, all that.
Uh,
Your
put-
logo.
put any image in
Yeah,
logo.
logo, please.
Okay.
Any logo.
And videos. It's all our videos.
Very good.
Day by day.
Very good.
Okay. We made also steel structure training. This one. And connections and how to connect. Very complicated one, how to connect to it and the angles.
So it does analysis as far as how it will hold against stress.
Yeah. Yeah, how can calculate the forces? Yesterday we made the wind loads and
Wind load?
Yeah, wind loads and pressures, forces, torque.
Everything.
Okay, it was a big lecture yesterday. And we discovered that this material, 2 millimeters, for example, yesterday, if you forget, yeah, it's made by 2 millimeters. Okay. After a check, we found that 1 millimeter also. It's okay. So I can save 50% of material based on this structure.
So for cost-
This is a real job study, was a real case study. Okay, we found at least how many kilos you.
Can I do this or no?
by
Yes,
hand.
yes. We saved how many kilos when we made it from 2 millimeters to 1 millimeter. We saved almost. We calculate the quantity. We saved almost 83 kilos.
Can AutoCAD do this? Do you have any modules in AutoCAD that can do this? Testing.
No, can't do stress. Yeah, can't do stress. Simulation. If you need to describe, we did
Yes.
simulation.
Yes.
Simulation. It's amazing because you will need actually what thickness of material you need, what type of material. You may use aluminium, will be better. It's okay, and we can use steel for 2 millimeters. I can use steel 1 millimeters, will be satisfied. Okay, and we explained also what's the safety factor, how it can be calculated, what's the yield stress, what's the tensile. Okay, the summary on the mechanical properties of material. Okay. Okay. Select a fixed entity. First, select your fixed face. Okay, these are base fields. Okay. Now, check dimension. Now I need thickness for 2 millimeters, for example. Okay, good. And bending radius will be 0.8. Or, as I said to you before, get a picture from the table on the press brake, please, and print it. Each one for you should have. Okay, inside there are important catalog, not catalog, important paper on the press brake machine, printing machine, which identify each thickness need radius, special radius. Okay, each thickness with its special radius. Okay, because in design should put here the bending radius. Okay, based on the in the document of machine.
So it tells you when you bend, what will be the radius of that bend.
Yeah.
based on the thickness and the type of
Yes,
material.
it's thickness. It's very important. Also affecting flatten. When you make a planking,
Mhm.
for finally make a planking for laser cutting, we discussed together and we show already when you change the radius and key factor, change the planking size. You will have not the same dimension. It's very problem in sheet metal. Only drive, this not here only. It's the problem. Sheet metal have two factors. If you can remember, key factor and bending radius. Okay, and also we have a good lecture here about that. Scientific lecture, not
What's
software.
it? Okay, bending radius, and what else is it?
Bending radius.
The other key factor. You said those two.
Okay, yes, key factor and bending radius. Okay. Now check your bending radius. Would be 0.8 or something. Up your machine. Here, bend edges. Bend edges. Select your bend edge here. See? Why made this? Oh, just something you need to do. These surfaces, each one individually, not connected. This surface is not connected. Okay, so you need to connect them. At least connect this one and this one. Yes? How? In surface. Need surface. Need surface. Okay, like okay. Need surface and select this one and the other surface you need to connect and click OK. Need surface and select this one and the another face and click OK. You will find here 3 bodies only. One body for these two faces and these two separated bodies we don't need now. Okay? If we'll go directly again to convert sheet metal and select your first face, it's okay, and 2 millimeters and it's okay, no problem, and select this edge. Now it's okay. Find this mark. Can change view. Find this mark, means the bending radius. Okay, so it's okay, and hide these two surfaces. Sheet metal, flatten, converted from just surface. Okay, if you need to make it from sheet metal from scratch, you can't, because these angles, it's very difficult to get. It's very difficult to get these angles together to be matched with this one. Okay, so in surface you can do just lines, just connect. All right, clear? And you can continue normally. Make your arm fold if you need to make a hole here, for example. Working with your concepts, you can use this cut in future, as you said before, and use this cut the same, just shortcut from each other. Okay, okay. Control 8. Put your circle. Okay, fold again, no problem. You see, actually, all right, okay. Now, if I need to make cut here, if I need to make a cut here, okay, without bending, without fold and unfold, it's a small difference in operation. In this way, this means that in DXF final DXF, we make right click export to DXF and WG and click save. Sheet metal pending line. Do you remember that? I review with you. Okay. The circuit would be with the laser cutting included in this laser operation. Okay, but if you need to make this hole, but this hole will be something, would be that another operation would be made after pending. After pending, okay, you haven't this hole, this cut no, these three features I haven't. Right click, suppress it, okay, and I will drill it after operation. Big difference. Why? Because here, if you get cross section, the thickness of sheet metal perpendicular on the faces. Okay, because this operation already made in laser cutting. Okay, but if you will do this just drilling, the faces be like that.
Yes.
Okay, all right. How you can identify it in drawing? You can identify in your drawing the steps of manufacture. So I don't need to make this feature like that. No. Normal cut. Sorry, control here. Normal cut. Just circle. Without unfold and fold. Just circle. Just through all from here. If you check, this is different.
Yes.
Clear? It's very important. Very important. What's the operation? Steps of operation. Okay. Okay.
So the issue would be like assembly. Case in point, if there's a shaft that's supposed to go through that hole, if you laser cut and fold, a shaft won't fit.
True.
So this may be some issues with assembly and construction, because if we don't take care as far as designing production, when you make it, the pieces won't fit together.
True.
Because you created a hole, but you didn't think about how you created the hole and how it will connect with the other parts, and will it have the functionality that you want.
Yes, true. I discussed before with Mr. Khaldoun when he started the course about this charging station. He told me that they would have a big problem for 6 months of trials, okay, for waste materials. Was it trial and or no, not okay, a change. Yes, that's okay, and when made it on software, and I will open it now. We match now the lock, okay, this lock to the door. Okay, just simulate on software with 2 days working. Yes, 2 working days. But after that, from first time, it's okay. There's a difference between.
So before the approach was trial and error, now we can use simulation.
Yeah.
Without wasting material.
Yes.
Is this the case? Any actual cases? Was this the situation? This?
Again, we don't have to prepare the sample.
Of course.
We can simulate it here and we can check everything.
But before you were putting together some trial and error, yes?
Yeah.
Now we have the option for simulation. We'll save a lot of time and a lot of money on material.
Yes. Okay. Differences are clear between them. Okay. And you can apply any feature of sheet metal now, because your part already has been converted to sheet metal by this one. Sheet metal and converts these features. Right? Okay. Also you can apply this forming tool. Oh, it's very big. Okay, get small one from software, forming tool, like that. Okay, all right.
So that stamp will make the U shape. When we open it's bigger. So can I, so if I do stamp there on this shape,
Yeah, yeah.
so I have to make small
Yeah. You
from
can.
the tool or I can.
No. If you go to this shape, okay. Good question. 3D CAD library and go to forming tool. This is our Unigraf U shape. It's very big. Okay. Oh, when make this like that, have a problem. This is not. Okay. So you can go to directly to this file, right click and open.
So we cannot add it there.
Yeah.
We have to go
Yeah.
for
Change. Go here and change this text file that we made. Okay. Change font. Small it, for example, with file. Okay. Just change this one, or not change, no problem. But recommended to be changed. Control S, save. Okay. Go to here, Unigraf. Updated. Just go to feature, will be updated from other file. Okay. Why updated? Because here I have link to form tool. Link to form tool. If you will remove this one, you already break the link. Okay. Link, unlink, link, unlink. All right. And change your position. Okay. Go to here and change the position of part. Not important this one. Just sketch. You can change it. Or from here. Change.
Question, that channel, is it open or closed? YouTube channel?
No, public.
public.
Yeah.
Public now. Because unfortunately we can't, if we close it, we have to use it in password. Separate or all the same? Can I use the same? See, this will be uploading from another for deleting. So that's good. If anybody has delete this, you have an access that it has. Oh, really?
Yesterday
This is, I say no, only go to the program.
Yesterday I checked the YouTube channel because I have the account to upload it. Okay, I found that we have 60 views from Emirates. Okay, and 30 views from Italy.
Yeah, exactly. What I'm asking. Yeah, that's what I'm telling you. Oh, you say,
Yeah.
Public, Americans, if it's public,
Italy,
everyone's have
from Italy, yeah, persons from Italy. And what you can say, maybe interested.
But Unigraf is there, huh? The logo
Yes,
not there.
Unigraf.
We have to get the logo. No, the logo not there.
We need to put the Unigraf.
Logo. Put the
Yeah.
logo.
I need the logo file
If
from
you
you.
give me
Okay.
the account and password, then I can change it.
Okay, if you can give me already your bank, we can do it together.
With sharing of information.
Okay.
This is even, it's something nice for the world. I'm not joking. Really, why you can keep the information and share it to anyone? The issue is that this information is will make the first time Eric told me this. Okay, well you told me you're different. Okay, no problem. The first time Eric said this to me, but okay, you special. I know. No problem. First time I've ever heard this. Okay.
Okay. Clear? Okay.
Well, if it's open, please get the logo up, please.
No, this is very important.
Yeah.
Today, please, huh?
Out.
Let's brand our. Let's take it on our brand.
Okay.
And you can mention your name.
Yes, okay.
Credit يا معلم. Instructed by Engineer Ahmed.
Okay.
But with all these things going on, there is a big issue with this website.
Yeah.
I don't understand. We're putting all these resources. The hub should be the website.
Till now we didn't start the website.
This is very
Okay. Okay.
You can put our name also, sir.
You have to put your name, yeah. Yes, the name of students, okay? Learn two. Arbab, Norin, Arnold, Hector, okay? And put already name of Mr. Shower, Mr. Khaldoon, managed by Mr. Khaldoon, okay? And Mr. Khaldoon managed by Mr. Shower, with the boss of Mr. Wissam, yes? Okay. Now we have to get something very important. If you have special cuts that we found in charging station, you see the lock of the main door, okay? You made this lock shape only circle. You made it as a circle, and this really not correct, because your lock like that, okay? Main lock button like that. Why this one? Your cut should be not circle, should be like that, should be like that. Okay, why? Because you're closing and opening. Now the lock rotate with you, okay? Rotate with you, okay? Depend only on the force of tighten the nut, the back nut, okay? And this is not correct really inside. So we need to make something very good. Now you have a server. Now you have a server, okay? About 1 year of working with SolidWorks, sure that you will face something, some products, some accessories you need to fit with your products. These accessories have its special cuts, special holes, special shape to cut, okay? Now we will make a library for this cut. We'll call feature library. This means that you will just drag and drop, drag this cut, tick, finish. Drag this cut, top, tick, finish. Okay, just drag and drop. Not each time get this cut from AutoCAD as a copy and paste it in another design. Okay, no. We will cancel this system. We will do something called feature library. Feature library. Okay. Let's see together something. If I have this lock, design, where design library? This no, my CAD library, accessories. I have this lock. We're using it in Egypt and in Saudi Arabia. Your lock have only 2 cuts here, 2 flat sides, okay, not like that. So if I need to make special cut, now I have a solid board, normal solid board, just you have a rectangle with any dimension you need. You have this cut, for example, with 60 millimeter, and you have and you will cut it. This cut, okay? This cut especially for some types of your locks, of your hinges, whatever, okay? We need to save this cut to be something like lacquer. Create a door with sheet metal and just drag and drop, okay? All right. Here, this one. First, click on the feature. We need only this cut, so click on the feature, cut feature, okay? And click file and save as port, leap feed port. Leap feed port. We used it before.
Library feature.
Yeah. We used it before, do you remember? Leap feed port. And type the code, the number of your accessory. And anything you can describe that this accessory, the cut of this specific accessory, whatever. For example, you have a lock called the lock 1030, for example, and you know, okay, and save. Thank you. Now we will get copy it, a good image. Right click, cut, and create, put it as a copy, as a paste. In this one, feature library, I have a folder called feature library. Right click, open this folder and paste this one. Okay, alright. Lock, 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 0, yes, this one. Okay? Good. We can open the charging station door. For example, its door. Sheet metal door, normal. Just drag and drop, tuck, tuck. Just, where is it, where is it, where is it, where is it? Look one. This one. Just drag and drop. Okay, I have another features. Just like that. I have two types. Okay. No, this error for the sketch because I didn't select the sketch. We select only the feature. Okay, the sketch should be selected also. Okay, should select all features, a sketch and cut. Okay, it's just error from my
From the saving tab, the saving.
yeah, on the saving. Yeah, I will show you again. New one. Something like that, for example, and you have to cut it. Okay, select this one and this one with shift, normal as Windows. Select multi folders, multi files, the same. File, save as, leap fit, blah 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 blah, anything you need. Okay. This library feature. You can drag and drop automatically from here also. Okay.
Also even
Sorry, you need a point. Sorry. You have a problem in the point. Sorry. Need a point. Need only point. File, save as. Yes, I know, that's I opened already. Another one. Close this one. Okay, now you can bring it with which one? I think this.
So
okay.
you can save it anywhere, sir. Any folder, you can just drag and drop.
Any folder, yeah? Yeah, complete any folder.
Any location.
Yeah, but I said to you why library? Because you will have a specific place on your server, a specific path. All computers can work on it at once. Okay, something different.
Even the first one, sir. Even the first one that they was with. We can save it anywhere.
Yeah. This is my personal library. I use it. You may have a problem. I will check. I need to check what's the problem here. May need to create point. Like that. It's okay. And drag and drop. This will save more times for you. Sketch point. Okay. No, this may be hanged. May something hang. Zero length, which one? Serving good information that consider. No, this may be hanged. Of dimensions. I haven't already any dimensions that you can use. What's the problem? You have some problem if you have something like that. When create it, remove this relation point. So should be free. Sketch should be free, because when you import it, you will import it in any place on another part. Okay, so the relation between this rectangle and shape not important, so should be free like that. And now you can delete this one, you don't need. Find file, save as final. Leave fat. Okay. If I will remove it. Okay, and remove this point also. And go to drag and drop. Understand what I do? Understand? Drag and drop should haven't any error. Alright?
So can we go back to the saving again? The one that we're saving for?
Save?
Save the file.
How it should. I will repeat it, okay? File new. Create your cut feature. It can be cut and can be extruded. Any feature. Okay? Cut or extrude, any features. cut. Select. Select your feature. Cut.
Only the cut extrude there will select.
Just cut. Okay. Not extrude. We don't need this one. We need only. Okay. File. It's still selected. Save as. Deep fit. Desktop. Cut. Cancel. Open your sheet metal part or any part, sheet metal, not sheet metal, whatever, and drag and drop. Where is it? Just click, put, bye bye. Okay?
So we should not select before, because before you select also the sketch. You select two.
No, I select here. I don't select it. Where? When I dropped it? No.
Not the first one, before.
Before. No. I select the feature, okay, and it will select sketch automatically. Okay. All right. Clear. Feature library. This will improve your time. Save time. After 1 year of working, you will have a lot of accessories. Just drag and drop. Your time will take minutes. Okay.